Let's talk about calcium release from the sarcoplasmic reticulum. In our previous videos, we've focused upon the contractile filaments of muscle fibers and the necessity to have calcium binding to troponin to allow all that to happen, to allow muscle contraction to occur. So what we're going to focus on here is how the ryanodine channel of the sarcoplasmic reticulum opens to release calcium in order to bind to troponin. So let's take a look. Here's a muscle fiber. Once again, we're talking about skeletal muscle really with all of this. As we can see right here, this is the sarcoplasmic reticulum, high concentration of calcium in here. The gate known as the ryanodine channel is closed. This gate is tethered to this voltage sensitive protein known as the DHP receptor. And as we can see in this cell is in a polarized state. Certainly I should have positive charges on the outside of this cell. I do not. But just please imagine there's positive charges out here. And dipping down into this cell is the transverse tubule, otherwise known as the t-tubule. And the utility of the t-tubule is to allow the spreading of an action potential or the spreading of a depolarization event from the perimeter of the cell down towards the interior where the DHP protein is and the sarcoplasmic reticulum is. So keep in mind that the change in electrical voltage, the transmission of electrical voltage is limited in distance. And theoretically, the sarcoplasmic reticulum is too far from the periphery of the cell to be activated or influenced by any change in voltage that happens up here. As a result, the T-tubule dips down so it can be closer in proximity to the sarcoplasmic reticulum. So let's get started with how this depolarizes. Once again, we need the cell to depolarize to activate or cause a conformational change in this DHP protein right here. So as you may have guessed, the depolarization event is going to be initiated by the influx of sodium. And this is dictated based on this channel right here, which is a nicotinic receptor channel. We talked about these when we were talking about acetylcholine, specifically cholinergic receptors, of which one of the types are nicotinic receptor channels, and that's what we see right here in teal. And certainly binding to this is going to be acetylcholine. So this right here is a neuron, specifically a somatic motor neuron, that when that gets excited is going to release acetylcholine, which will then proceed to bind to this nicotinic receptor and open up that channel. This is all occurring in a region known as the neuromuscular junction. That's the point at which the neuron comes in contact with the muscle fiber. Now, I'm not showing it here in this depiction, but this is a gated channel. When this gate opens, it's going to allow the influx of sodium through this ligand-gated channel. Certainly, it's a monovalent cation channel, letting potassium out as well. We're not concerned about that because more sodium is going to come in down its electrochemical gradient than potassium leaving. But that's going to activate a number of voltage-sensitive sodium channels. And this is exactly the same scenario that happens along the progression of an impulse down axons in a neuron. So we are going to get this depolarization event traveling from this nicotinic receptor along the sarcolemma down the T-tubule. And that transmission of impulse is due to each and every one of these voltage-gated sodium channels, which I am depicting in green. And then once that change in voltage hits the DHP receptor, it's causing a conformational change in the DHP receptor, which pulls on this tether or wire or rope, however you want to describe it, that's physically connected to the ryanodine channel, opens up the channel, and because there's a high concentration of calcium in the sarcoplasmic reticulum, calcium is going to move down its gradient into the cell where it will then proceed to bind to troponin. Troponin will then undergo its own conformational change to move tropomyosin out of the way. Thick filament can grab the thin filament. We covered all that in the previous video. But one thing I want to show you is here's a DHP receptor. And this is what it looked like at the beginning. So the depolarization event caused a conformational change to create tension on this wire right here, if you will. And once it undergoes a conformational change, it pulls open the ryanodine channel. That is the release of calcium from the sarcoplasmic reticulum, initiated by the somatic motor neuron, releasing acetylcholine, allowing the influx of sodium. And then we have this whole domino of voltage-gated sodium channels that progressively lets sodium in to allow that depolarization event to travel down the T-tubule, cause the conformational change in the DHP receptor, opening the ryanodine channel, calcium moves out. Okay, that's it for tonight.